This video helps with the dimensioning of thyristor power controllers and provides basic information on the topic. Thyristor power controllers can only switch AC voltages. Nevertheless, the short introduction is based on the example of a DC voltage. If a DC voltage is applied to a resistor, a DC current flows through it. The existing resistance is the voltage divided by the current. The power converted in the resistor is the product of voltage and current. The current flows from the so-called plus to the minus pole. An alternating voltage changes its current value sinusoidally. The voltage lies between the so-called L conductor or phase and the N conductor, also called neutral conductor. In most low voltage networks, the alternating voltage between the phase and the neutral conductor has a peak value of approximately 325 volt. If the peak value is divided by the square root, the result is the effective value of 230 volt AC. AC denotes the alternating value and stands for alternating current. When the alternating voltage of 230 volt AC is connected to a resistor, the same power is produced as by a direct voltage of 230 volt DC. DC stands for direct current. Usually a frequency of 50 Hz is present, so there are 50 sine waves per second. The two formulas for electrical resistance and electrical power also apply when an alternating voltage is applied. If, for example, a current of 23 amps is reached when an AC voltage with an effective value of 230 volts AC is applied, the consumer has a resistance of 10 ohms. The product of voltage and current results in the power. In the example, this is 5290 watts. If the voltage between the phase and the neutral conductor in a low voltage network is 230 volt AC, consumers with a nominal voltage of 230 volt AC can be operated directly on this network. The power can then be varied via a TYA201. The voltage between the phase and the neutral conductor is the phase to neutral voltage. The control electronics of the actuator are supplied with the same voltage. In the case shown, the actuator must also be designed for the phase to neutral voltage. Generally, information on the nominal voltage and nominal power of the heating elements is available. If, for example, a heating element with a rated power of 7 kilowatts and a rated power of 230 volt AC is used, it is operated in the usual low voltage networks between phase and neutral via a single-phase thyristor power controller of type TYA201. By dividing the power by the phase to neutral voltage, the current through the consumer is obtained. This current is switched by the controller. Therefore, a TYA201 must be designed for at least this current. A thyristor power controller for a maximum load current of 32 amps is used. The controller must be designed for the phase to neutral voltage of 230 volt AC. A total of 3 phase conductors are present in the low voltage networks. The voltages between the respective phases L1, L2 or L3 and the neutral conductor are equal. As mentioned before, this is the phase to neutral voltage, which is usually 230 volt AC. The voltage between two phases, for example between L1 and L2, is the phase to phase voltage, which is obtained by multiplying the phase to neutral voltage by the square root of 3. In a system with a phase to neutral voltage of 230 volt AC, the phase to phase voltage is approximately 400 volt AC. At this point, the notation for a three-phase low voltage network with a phase-to-neutral voltage of 230 volt AC and a phase-to-phase voltage of 400 volt AC is shown. Consumers with a rated voltage of 400 volt AC can be operated between two phases, for example via a TYA201. Nevertheless, it is still called single-phase operation. As an example, the dimensioning of an actuator for a heating element which is operated between two phases is considered. The heating element must be designed for the phase-to-phase voltage of 400 volt AC. The same applies to the TYA201 thyristor power controller. To determine the controller current, the rated power is divided by the rated voltage. In this case, it is the phase-to-phase voltage. A controller for a permissible current of 100 amps must be selected. Especially bigger loads are operated in three phases. In this case, the heating elements consist of three partial loads. These are connected between the three phases and the neutral conductor, for example. The loads can be arranged in a star. This is why the structure is also called star connection. In a star connection, the phase-to-neutral voltage is acting on the partial loads. As mentioned several times, this is 230 volt AC in most networks. The current through the phase conductors is the total power divided by the product of 3 times phase-to-neutral voltage. Alternatively, the total power can be divided by the product of the square root of 3 and the phase-to-phase voltage. The UMO TYA202 or TYA203 controllers can be used for the three-phase operation. As an example, the application of a three-phase load in star connection in a low-voltage network with a phase-to-phase voltage of 400 volt and a phase-to-neutral voltage of 230 volt is considered. The rated power of the three-phase load is 80 kilowatts. The controller current can be calculated with the two formulas. This results in approximately 115 amps. A controller for a permissible load current of 150 amps must be used. The controllers for three-phase operation must always be designed for the phase-to-phase voltage. In the example, these are 400 volts AC. Three-phase loads are often operated in the so-called delta connection. In this circuit, each partial load is connected between two phases. The phase-to-phase voltage is applied to the load. For the current in the phases, respectively for the actuator current, the same formulas apply as for the star connection. The dimensioning is to be considered for a three-phase load with 130 kilowatts nominal power in delta connection. The controller must at least be designed for the current according to the formulas. A controller for the maximum current of 200 amp AC is used. The controller must also be designed for the phase-to-phase voltage, that is 400 volt AC.